This is a very interesting question. A good use of technology is required, and students are also required to state answers in exact form. So to graph this function, I'm using autograph. Of course, in your case, you probably be using a GC, and you get something like this. An intercept at 1/3. The curve passes through pi over 2 and 3 pi over 2, and note the location of the maximum and minimum, right? Okay, and the intercept, of course, of 1/3 can be observed from the diagram, and here you can also calculate like this, or just state the zeros as pi over 2 and 3 pi over 2 respectively. And here, for this indefinite integral, I'll just using the technique of substitution. You should be able to arrive at something like this. Don't forget the absolute of the function. And the next part, just use part C, right? And this is a definite integral, but of course this unknown a doesn't matter. Substitute that 0 and a into this integral, and you end up with this is something you're supposed to show. And then this gets interesting, and using a graph, you or method that you prefer is supposed to actually state the what is the value of a when this is minimum. Now I'm going to explore this a little bit to describe here what is going on. Okay, and right here, alright. So now this is not about area under the curve, but in this case it's the region bounded by the curve and the x-axis. And here you see it is 0.25, but once it passes through the first zero, you see the values get smaller and smaller, and they ask you when would this value be as small as possible. Well, of course it's when it's at 3 pi over 2. And when will it be the most maximum? Of course, right here. Okay, when 0 is pi over 2, or a is pi over 2. So that's the reason why we state that it's minimum when a is 3 pi over 2. And as for here, a is pi over 2 for it to be maximum. And of course, the corresponding minimum and maximum could be calculated just by substituting the values of a respectively. And I hope you look at the other videos later, and all the best.